I'm Dave Fowler. I'm the founder and CEO of Chartio, and here to talk about Kimball in the context of the modern data warehouse. And basically, so a little bit about myself. I started Chartio about a decade ago, entering the BI space. We are a BI product with the mission to enable anyone in a company to explore and understand data, not just data teams, but really everyone. Toward that, we compete with like Looker and Tableau and Mode and other products there. One of our big differentiators and innovations is we've created what we call visual SQL. And like Windows made DOS visual and enabled way more people to work with computers, and even power users can use the graphical interface much better than the terminal for most things. We want to do the same thing to SQL, and it just writes SQL directly. And so visual SQL with Chartio. We've also started dataschool.com, where we write a lot of books in education. So we found just this space is very self-taught, and we wanted to help teach. And so this deck here is kind of a result of all that stuff. It's an open community of education. So we want to get other data people teaching and learning together. And so, head on over there sometime and check it out and participate. We love more involvement. And yeah, you can chat on the Slack. My co-author of a book we're publishing soon, Matt David, is there to answer questions while I do this talk. So first, we're going to talk about Kimball. I give a little intro and a really high-level intro to what dimensional modeling is and what problem it solves. Then we're going to talk about, we're going to kind of break it down based on the reasons Ralph said dimensional modeling was important. And then for the things that differ, we're going to talk about what to do potentially instead. So a lot of things here, and it is a very contentious topic. I'm a little bit nervous at the moment talking about all this, but very excited about it again. And so before talking about this, Ralph, for very good reasons, has a very passionate following. And sometimes I call him kind of the Freud of data. And in the early days of psychology, anybody who wrote a book that differed from Sigmund Freud, would have to write 2 chapters really defending, one praising Freud and then defending like why they're very softly going to make some suggestions on improvements. And so I feel a little bit sometimes that way with Kimball. He's a very passionate topic. But we're not going to hear correct Kimball, and we're not looking for any faults in Kimball. Really, I think this guy's a legend. If I look at his career, PhD in electrical engineering at Stanford, he was part of the first graphical user interfaces at Xerox PARC. He created the first visual programming language, which me creating visual SQL, I'm so impressed. He feels like a really just way better version of me. So I'm very humbled to be talking about Kimball today. He also formed the Kimball Group, which you can kind of think of as the Fishtown Analytics of the 90s and the 2000s. They were huge. And he authored 5 books, which are all very good books. Most famously, he wrote this data warehousing toolkit, which is a big bestseller. And when I was starting the data school, I talked to many data analysts and found out how did you learn data? What got you into data? And how did you get to your skill level today? And almost everyone was self-taught. And there's so many different ways of learning data. And this was the most consistent book that came up. Only about 30% of the time, but people did reference that this was one of the books that they kind of read for data modeling. Kind of like Claire just said, she kind of knows about it. She read it. She knows this is the main book on it. But there's just some confusion around it. It's an amazing book. Part of the problems with it, though, is it's very old. The last edition was published in 2013, just a couple months after Redshift was launched. And so it's pre-cloud, warehouses. And the second was 2002, and the first, I couldn't even find when the first one was published. And so data's changed a lot over the last couple of decades, a lot. And so, we're going to take a look at, does this stuff still hold up in modern day? Should we still be paying attention to this? And I want to go into just the problem, high level, for those of you not too familiar, give a little bit of context on what analytical modeling is and what Ralph Kimball was solving in the Kimball dimensional modeling. So there are things out there called transactional models, and this is the format of data that's in production. So your application databases that your company's using to run the product, your Salesforce, your HubSpot, all the kind of models that you get directly reflected from Fivetran or Stitch or other products like that. They're going to still be in this transactional format. And they're structured in a way that made sense to some engineers, and it makes sense to run day to day. And it also changes whenever the engineers want to, and it doesn't change when it maybe should, but the engineers don't want to for various different reasons. And so it's really important when you're doing data analysis to make a new schema of that, a new view of that, and separate from that transactional model so that you can, really make it clean and not repeat yourself so much, and so that you can more easily digest the data. And so that's an analytical model. And Ralph really pushed star schemas and dimensional modeling. And so that's a form of analytical modeling. We're going to take a look at it here today. And so this is how to basically take the same data that your company's running on, but structure in a different way so that you can more easily digest it for analytics. So to look at this, I kind of want to use Kimball's own reasons. So in the first chapter of all of his books, he really puts a whole chapter really breaking down and making the argument for why dimensional modeling is important. And in those books, he has three main reasons why dimensional modeling is important: cost, performance, and understandability. And so we're going to use his own three reasons and kind of look at those with a modern look at stacks today. Are those still good reasons? So cost then, what data looked like, 10, 20 years ago was storage was very expensive. And even for what we call kind of small sets of data today. And then also it was stored row-based. And so this table above, if it's stored row-based, it looks kind of like in the gray below is how it looks on the database. It looks very much like a CSV file, you would think, and it's just stored by row. One of the problems with this is, you can imagine, if this was 1 billion rows and say 1 million people lived in San Francisco, well, you're storing that word San Francisco 1 million times, and maybe you don't need to. So that can get very expensive when you're doing all this extra storage. So Kimball had this approach, and this was one of the reasons why he suggested doing a star schema. And you take those columns that get repeated a lot, they're called dimensional columns, and you break them out in their own tables. And then you take the unique, the highly changing data, which is called facts, the measures, and you put that in a separate table and you foreign key to the dimension tables. And so there's a whole separate table of all the cities, and they just foreign key into the fact table. And so San Francisco doesn't get repeated 1 million times, it's just used once. And that saves storage. Today, though, things are a little different. Now, in 2005, a white paper came out, C-Store data paper, C-Store white paper, and it really had a lot of great innovations in it that created, ultimately, Redshift, BigQuery, and Snowflake, and a number of others. And it totally kind of flipped storage on its head and instead stored things columnar store. So the same table above now gets sorted very differently. And you can see San Francisco is next to each other. All the different cities are next to each other. And when they're next to each other, it's actually very easy for a computer to compress it. And so the data gets really compressed in that format automatically. So you don't have to go through the manual effort of separating dimensions out on their own table. It's happening automatically for you. So that cost difference is just not really there. And that's a big, big change. The other thing that's changed is data storage has gotten very, very cheap, while skilled labor still remains very high. And so, really the storage cost has really gotten quite insignificant when compared to the cost of labor. And so anything that can save you time is going to be the better cost thing, and storage isn't really a factor. And so when we consider costs now, I would say wide tables, just making a really wide table, don't break it up into all the different stars, is a vastly superior way to store the data. It takes less time, less training to implement, less knowledge there. And the performance, we'll get into performance in a minute, but the storage cost is pretty much equivalent, but the people cost is actually way lower. So for the cost reason, I think wide tables win. When looking at performance, so our friends at Fivetran and Michael Kaminsky wrote a great post benchmarking star schemas versus wide tables. They called them one big table, and checking the performance on that. And as you might imagine, star schemas, they're going to require joins, and the wide table aren't. And so Fivetran found that wide tables are actually 25 to 50% faster, really across the board. And yeah, so for Redshift, Snowflake, and BigQuery, 25% faster. There's a great article there. Maybe Matt can share the link in the Slack for those of you who haven't seen that yet. So performance-wise, wide tables really win. And then understandability. So this one's a little bit more subjective. Ralph says he did a lot of user tests and found star schemas to be very intuitive to business users, and experientially found that as well. And I think he was comparing it more to transactional schemas, or even potentially operational, where, I would argue a little bit there, especially people are a little more tech savvy, get how objects work together a little bit more these days. But compared to wide tables, it is hard. Like, star schemas seem to organize a little bit, but I think ultimately when these things are put into BI products and used by those end users, the winner is still wide tables here. And they just play better. A lot of BI products like make you put them into wide tables. Chartio doesn't, but a lot of them do make you put it into a wide table format anyway. And also, frankly, business users don't quite get the concept of joins. It adds more complication. They really do get spreadsheets. They really do get the concept of a big table. And we've learned that through a lot of user experience tests ourselves. So I think here, although it's a little more subjective, wide tables may win on that. So all the three reasons that Kimball states for using dimensional modeling, I think were all correct in their time, and his insights were huge and really helped everything at the time. But with the advent of cloud data warehousing and column restore data, I think these have largely gone away. So this is a controversial statement. I'm stating it very boldly because I think the community needs that, and I think in Ralph's honor, like, he would respect that and appreciate it. And it's a contentious one that I would love to see more debate on, but I'd also love to see it kind of settled. And so I'm speaking kind of boldly about it. So if you support it or don't support it, I'd love to see your comments. So frankly, like, the dimensional modeling, this book is called The Definitive Guide to Dimensional Modeling, and we're saying maybe don't do dimensional modeling anymore, do it in kind of a different way. Well, what is that kind of different way? And that's what a lot of people are asking. And a lot of people say, well, do Kimball light, or do, kind of Kimball, like, learn a bit from Kimball, but don't do it quite that way. And well, what way should I do it? And that's what's really missing, I think, for us to be able to move on from this book, which again serves its time for many, many years as a fantastic book, but I don't think should be part of the future. I think honestly, new data analysts that come to me and ask questions about this, like, I think sending them this book maybe does more harm than good at this point. And so we're going to go over a few things for how to do modern agile analytic modeling. And the first we already pretty much covered is you should use wide tables. Just make big wide tables instead of star schemas for your analytical modeling purposes. They're more intuitive to architect. They're a lot easier to learn. If you imagine somebody who's a good data analyst, knows SQL really well, but maybe hasn't read the Kimball books, to have them go make star schemas versus just make big wide tables, you can imagine the learning curve difference there. So they know how to make tables. Everyone, people who know how to write SQL know how to write tables. So they already get the concept of granularity. Also, they don't have to know the difference between, facts and dimensions, because those, in a wide table, they get treated the same. You're just showing them all. So there's not like this special things you have to do. There's a lot of extra little things in star schemas that you have to learn that you just come more naturally if you just tell people to build wide tables. And it sounds maybe simplistic. It doesn't sound sophisticated, but that's part of the power of it. It's the best. Like, do that. You get better performance. It's easier to execute. It works better with BI products. Actually, a lot of BI products allow you to make an Explorer or a data set or, these things inside the products. It's always great to do it with DBT, and then you can run tests and stuff, and that's a great way to do it as well. But sometimes you want to just do a quick one, or you want to iterate or experiment, and it's nice that you can do that in most BI products. So, and again, it's more intuitive. So for analytical modeling, do wide tables. And your stack's going to look like this then. So we're going to get more into this. So I want to intro this. Basically, I think people are familiar with this. You've got a lot of data sources. You ELT them into a lake. They're still in transactional schema. They're still in the same exact structure. And then you use DBT or your BI products to build a different view on top of those to make your wide tables, your analytical modelings for digging through the data. Covering a lot here, so I hope you guys are following, and I hope I'm going at a good pace. The second thing is I really want to encourage people to not, we as data analysts really think about analytical models and our wide tables, but really so much more power and strength is in the operational modeling. And I think that should get a lot more attention, a lot more effort than, frankly, the analytical modeling. And so we talk about those today. A lot of Fishtown talks about those in making staging schemas. And we're going to talk about another form of operational modeling too. But that's exactly right. Making staging schemas before you make your wide tables. And what a staging schema is just a better, cleaner, more organized, better named version of your transactional schemas. So it still looks very familiar if you know this transactional schema. Looking at this operational schema, the staging schema of it will look very familiar. Many things will be named very similarly, if not the same. And it's still normalized. There's relationships between all these tables. It's not in a star pattern. And doing this cleanup step is huge for cleaning that data and building your analytical models off of it. If you do it here, it's much faster to do here. It's much more intuitive to do here. And then your analytical models will just have to be a lot less complex when building off of this. And when something changes, you don't have to change 8 different wide tables. You can just come here and change it in the staging schema. So it's a huge benefit to make these staging schemas and do this operational modeling. And again, sometimes I like to talk about it as basically you take your transactional schema and you put it in a suit and you give it a haircut and shave. So it's like kind of the same schema, but it just looks a lot better. It's cleaner. It's more public facing. A third thing that people get a little nervous about, because it kind of brings up like Inmon, and that's really older stuff, and it sounds really overwhelming, the idea to make a warehouse in a single source of truth. But I think today, if you have really good staging schemas and you're using DBT and you're using SQL, it actually doesn't take that long. We've done it here at Chartio, and it really only took us 1 month to get this warehouse up and going. And it's just been life-changing. It's just been game-changing. And so to describe this warehouse / single source of truth, sometimes I like to call it Atlas Force Interhub Mark Zen DB. And I use this because it's a magical name for a magical database that doesn't actually exist. And you can imagine a world where all of your data, all of your systems run on one perfect, clean, beautiful database. Wouldn't that be amazing? Wouldn't that be nice? Like all your company's information, you can find it all just cleanly organized in this single database. The reality is we don't do that. Companies have 30 different SaaS applications, and our transactional databases for our applications are just a mess. And so that's not the reality. We can't really have that single beautiful ideal data source, but we certainly can make a view of it. We can make a version that looks like we have that. And it's really not all that hard and intimidating to do. And when you do it, it's really game changing for your company. And when you're building your analytical models, or sometimes you don't even have to go off the analytical models, you can just go and query off this warehouse, this single source of truth. It's really game changing. It's a really great thing to do. So the more time you put here operationally, and not just making analytical models, but clean operational models that still look like they might be working applications, the better you're going to be. And to be honest, also, even exposing these to business users, we find business users do find these operational warehouses still quite intuitive, not quite as intuitive as one wide table, but there's also limitations to that wide table in that, it can't do the joins and things like that. But it's very, very powerful to make this single source of truth. So my fourth tip, stay agile and iterate. Don't do things that, really keep trying to do things that make you increasingly agile. And again, making more of these layers that are like operational layers helps you be more operational, helps you like change things in one spot and be more nimble as a company. Because the thing and learn in data is like data changes, questions change, businesses change, people change. Everything really changes inside of a company. Even best practices, as we're going over here, they change. So stay agile, stay nimble, and iterate. It's a huge, huge tip that we have. And fifth, and this is again, just hammering this home today and being a little bold, with all due respect to this book, it was awesome, but I think today, unfortunately, it's doing more harm than good. We should really kind of leave this in the past. Claire, don't bother reading it. Maybe in your job, it's important, to get more familiar with it. But honestly, I think like, let's move forward from this. And it can be just more complicating and intimidating for people than do actual good. And lastly, so we can't just say don't do the book. People are looking for answers. People are looking for what should I do instead. And so, we realized that we launched a book about a year ago in this article. We need new data books. So we started one, and it's called Cloud Data Management. It's for free online to download at dataschool.com. And we're making a much bigger version of this that goes a lot more in depth with data modeling. And we're publishing that with Wiley early next year or mid next year. And so we're working on the final drafts of it right now. We love to talk about this. We love to test these ideas with people. That's one of the reasons we're talking about it today. And so please join us in the Coalesce Kimball Slack channel.